Alright guys, how is it going today? It's been a little while since I made a video, and I've been kind of craving making one, so I wanted to kind of go through a key piece of homebrew equipment, which is the Inkbird temperature controller. A lot of guys I know, it's for just a little bit more money, are getting the pre-made Inkbird. Was it the 308? But it's also nice to build your own using one of these temperature controllers. It accomplishes the same thing, but you can customize a whole heck of a lot more in how it's used, how it's displayed. A lot of guys with this will maybe integrate it with in the collar of a Keyser. Mine is just a standalone unit that I hook up to both my fermentation fridge and my keg dispensing. I use an old upright freezer for my kegs for serving. Yeah, the main unit is the Inkbird. I forget the exact number, and then the outlets for controlling whatever you're doing. I'm going to open this up and show you what I did. Maybe look at it and go, ugh, what was that guy thinking? So I decided to use a 4x4x4 electrical junction box. You can use anything. You can use I don't know, a cigar box. You could use you can use your wife's Tupperware. You can do whatever you want as long as it is enclosed, because there is 120 volts if you're in the United States, or I don't know, what is it, 230 in Europe. You don't want exposed electrical power ever, because that's just, it's a risk for you getting shocked. It's a risk for any kind of combustible getting close to it, causing any kind of an arc, starting a fire. It's the last thing we want to do with our fucking hobby, is blow shit up. So everything is kind of nicely tight inside of this unit. I do remember when I built it, it would have been nicer to have it longer or rearranged a little bit better, because it is a tight squeeze from the outlet here to the unit right here. But yeah, I'm going to slowly take it apart, show you what I did. But along with doing this, I did also want to kind of explain how this little fucker works, because I mean, a lot of guys can follow instructions. You hook the power up to 1, hook the neutral up to 2, blah blah blah. But it also takes, once you have that second level of understanding on how this actually regulates the power, tells it to turn on and off, you're gonna have a better understanding on why you're doing it, and how to nicely hook it up. So I'm gonna start just kind of pulling it apart. Maybe I'll find some new wires when I put it back together, because it is, especially in tighter enclosures like this, it is nicer to use stranded wire. You can kind of have it go where you want it to go, do what you want it to do. So yeah, I'm just gonna start taking it apart, and once I get it all apart, we'll kind of go from there and figure out how to assemble a box like this to make it do what you want it to do. All right, so I do have it apart now. This unit is pretty nice because it does have all your instructions right here on what's really happening. So right here's our power coming in. So we have to have constant power on 1 and 2, and then number 2 will be our neutral. That is to give this unit right here power to think. So that is always going to be on no matter what. So it's not on an external switch. We're going to have constant 120 volts coming in, or it says 110, 120 volts coming in, neutral coming out, and then it's going to go, see right here, it's also tied in. We're going to have a constant hot power coming to number 6, and a constant hot power coming to number 8. Oh, it looks like I got it backwards. heating, cooling. Yeah, I don't know what the little dots are right there. But yeah, we have constant power coming into 6 and constant power coming into 8 and also into 1. So it's thinking within the circuit between 1 and 2, and then the temperature sensor right here between 3 and 4 is going to tell it to either close the little tiny switch inside to light up between 5 and 6 so it will heat, or close the switch here between 7 and 8 so it will cool. Let's see if we can open this up, maybe take a look at the circuit, see what we can figure out on what is going on in there. I don't know, let's see if I can try to break something, huh? Oh, of course, the sticker's on this freaking cover. So here's our buttons right there. And here's our 7- display. There's got to be a couple screws under there, huh? Or was this just slide out? No, there's a screw somewhere. But I want to peel this off. That'll be okay. Maybe there isn't screws. Let's put her back. Oh, it just slides right out. So it's a pretty simple circuit. These are just relays, and a relay is basically a mechanical switch. So instead of a on-off light switch, it's all being done in here. I don't know what this big bastard is. A couple capacitors. Yeah, I don't even know what I'm looking at. So all of our thinking is being done inside of this little chip here, connected with the little display there. This must be some big, this has got to be the transformer. 110 volts down to 10 volts DC, or yeah. So it looks like our power comes in here, our neutral comes back out here, and this is our, yeah, this has got to be our 10 volt transformer. Yeah, easy enough. But yeah, these are the main components right here for diverting the power on and off. And yeah, it's a pretty simple device. Let's put it back together. Nice, just kind of goes right back in. Easy enough, man. Put the sticker back on. So I'm going to kind of draw what's actually happening. Get a pen. So right here our power is coming into number 1. So 1, 2, 3, and 4 is our temperature probe. 5 and 6, 7 and 8. So that's our heating and, sorry, maybe I should put it in the frame, huh? So our heating and our cooling. So here is our 120 volt hot coming into number 1. We're going to put a wire nut here and go to number 5, and we're also going to go to 7. So this is still constant hot, it hasn't been switched. And then out of 6 we're going to go to an outlet, and out of 8, we're going to go to an outlet to control our devices, and then the neutral on the outlet is going to also connect up with number 2, which will also be our neutral. It's a pretty simple setup on how it's all going to work. Here's my outlet. I color coded them so I know what is going to, or how to plug it in once I'm all done. Let me pull out this tape. So one thing to remember on an outlet is that both of these screws, unless you do something, are electrically connected with this little bridge tab right here. I removed it on the hot side. So we're going to have a separate power switching just this top outlet, and then a separate power switching just this bottom outlet. Let me pull this stuff apart here. So yeah, we're going to have 2 separate wire leads. So the red one, this wire, is essentially going to connect up with hot out number 6 here. And then this blue one, this bottom screw, will connect up to this number 8. And then this neutral right here is this neutral coming from the outlets, which will also connect up with the neutral from our house power, also connecting to number 2. So all the neutrals are connected together. There is no reason to run 2 wires since they are electrically connected right there. And there is no reason whatsoever to break that and run 2 wires unless they are 2 completely separate circuits that you are controlling, which is the next level of hooking this up. If both of your pieces of equipment were drawing a whole bunch of power per each one, let's say your fridge for some crazy reason draws like 15 amps or even 10 amps, you're not going to want your heater on the same circuit. You're going to want separate circuits just so you're not tripping breakers. So that would be the reason if we wanted to break this tab, and then we would have 2 completely isolated circuits just on the same outlet. And then obviously you ground everything. If there's a ground, just freaking ground it. Obviously this is all plastic, so you don't need to ground this. This box is all plastic. You don't need to ground this, but you want the ground on the outlet. So you're grounding your refrigerator, you're grounding your heat source, because you don't want the metal framing of any equipment to become hot. Walk in your basement, walk in your garage, go to pull a beer, your thing's not grounded, you grab the handle and you shock the shit out of yourself. No one wants to do that. So this is my little cheapy way of going about it. I just took some Sharpie on these guys here so I know that this is cooling, know that this is hot. So I'm not fucking around trying to figure out what's what. Another little thing I did, which is completely unnecessary, is I added these little toggle switches. So if I don't want it to heat, I can just unplug it and it would be just fine. Or I can add these toggle switches, which I basically will put right here on the lead before it goes into the relay in our ITC-1000, and I can put another one right here. So then I can open up the circuit before it even goes into our temp controller if I don't want it to heat. if I don't want it to cool. It's totally unnecessary, but I have these little fuckers laying around. Cheap little switches. They're good for 15 amps at 125 volts, so they're good switches for what we're doing. You never want to use one of these switches that are good for 2-3 amps on a fridge that's probably drawing 6 to 8 amps, especially on when it kicks in. So we got 2 of these. What I'm going to do before I put it back in though is get them colored, because I'm always never know which one is which. So I'm going to try to find my Sharpies. I have no idea where they are. Oh, there's a blue one right there. So I'll color one blue right now just so I can get it hooked up the way I want it to be hooked up. I'll start putting this thing back together. So this time I do have some stranded wire. It's going to make things a lot easier. Oh, I suppose I could tell you what I did here. Basically, I just measured it out, cut a slot exactly that size. This side was a little bit harder, but what I ended up doing, so I essentially took a wall plate cover, held it over, and traced it, figure out where the hole in the center is going to be also, and then used my Dremel tool, which don't look pretty, but it helped, whatever. Use my Dremel tool to cut these out, cut out my switches, and cut this out. And then here is a 1/2 inch cable connector for my power source, this green one here. One thing I can say about this is though, if you're ever at your big box store, if you're ever at Lowe's, Home Depot, whatever, always look for discounted extension cords, because you never know when you're going to need them. This one I bought, it was really cheap, and I bought it probably almost 2 years prior to even making this, because it was like $4 for a 10-footer. It's only 14 gauge wire, so a 15 amp circuit would be just fine. Or if you're like me also, I am on job sites all the time, and on job sites they're always throwing out extension cords, because if it gets a break in the center, if some idiot decides to chop off the ground on the plug, if it gets ran over by a lift, breaks the outside, exposes the copper, the thing's junk. Contractors aren't going to mess around because that's a huge OSHA fine. So for usually they'll just chuck them in the garbage. I grab them, I bring them home, because I know I could just cut it up. I can use cords for all sorts of little things. You can always put your own little cord end on there. That's what I did here. You can always put your own cord end on. It's nice to have this kind of shit laying around. And I know this probably isn't the best way to go about it, but I just put my temp sensor in the same connector. You could always get it a separate connector. You could even go as far as getting like BNC style, but it's a low voltage connector. You can put it together, it twists together. You'd have to do some soldering on the inside, I'd assume. But if you wanted to be able to like disconnect and not have these cords dangling out at all the time, if you wanted to move it around or anything, that is also an option. But mine is staying put. I really don't care about this cord hanging out the back end. But yeah, let's kind of put it back together. So we'll put one in. Right there. And the second one in. Right here. Now I don't have a meter, but so I don't know which. I guess the meter wasn't going to help me, but I'm going to orient these the same way, just so that both one way is on, both the other way is off, so they're together and not flip-flop, because that'll be just kind of a mess. So yeah, we'll take 2 of these wires out. and hook it onto here. This is the bottom one, which is the blue, so this will go into number 7. The top one, which is not colored, it'll be red someday if I can find a red marker. That'll go into number 5, heating. And then we need our wires going out to our switch, our outlet. It's unnecessary, but I like to tape up these ends. It's kind of the commercial electrician habit of mine. It's just taping this stuff up. Granted, it's really only necessary in a metal box if you're going to be taking things apart hot, but I still like doing it. It covers everything up. Less variables for things to fuck up. I also matched outlet on the right is blue with the switch on the right blue, red, red, just for a little bit of consistency when you're kind of messing with things later. It's small little details that really help you out in the long run. So we'll add a jumper cable to this. Strippers is gonna suck. Number 1 is going to be, see, this is stupid. I guess this is our load right here. It wants us to put the neutral on number 1. I don't think it should matter. Well, yeah. Well, since that's what it's showing us, we'll put our power on number 2 and our neutral on 1, because I guess this little dotted line, that is our load. That is what we are controlling. So our heating, our little light, or cooling, our fridge. So yeah, let's get this in there. Number 2. We'll get a little chunk of white, put that in number 1. And all this will be hooked up to is our neutral power coming in from our green, or whatever color, our power that we get from the wall. And it's going to be hooked up to the neutral on the outlet. We do not control, we don't need to turn on and off the neutral. We're just turning on and off the hot power. Shit, I'll do this right now. The only thing we need to ground is our outlet. So I'm gonna get this tied together right now and tuck it in the bottom and get it out of the way. Because this is starting to get to be a situation where it's 10 pounds of shit in a 5-pound bag. And the more stuff we can shove in the back, get out of our way, it's going to make it a lot easier for us in the end. And same with our 2 powers going into our outlet. We need to tie these to our other sides of our switches. So this is my bottom one. Hook it up with the bottom one. This is both for cooling. And then this one, the top and the top I tie together. And then I can shove these in the bottom too, get them out of the way. These can go back in this corner. So then here's our power coming in. We also need 2 more leads coming out of here to get our power. So yeah, we can tie our neutrals together. This is getting to be a mess. A lot of wires in this box. And then we have our three hots basically. We'll tie these three. So this is port 1, port 5, and port 7, plus our hot power coming in. All these will be tied together. And we can't forget our temp sensor. That goes to 3 and 4, and it should not matter which one is which. If it did, they would label them differently. All this is doing is reading the temperature. There is a device in there that probably physically moves microscopically, electrically. And when the temperature goes up, it creates probably less resistance between 2 points. And when the temperatures cool down, 2 points create more resistance. And that gives a voltage value, probably ones and zeros, back to our unit here. And our unit knows that those values that it creates, whether it's ones and zeros or hertz, different frequency it creates, our computer inside of here knows what that means. It's been programmed to know what those values mean in relation to, in our case, a temperature. Same kind of sensor can be used for probably all sorts of shit in the automotive industry, for probably speedometers, things like that, for any kind of movement, flow within a pipe in any kind of industrial setting. I remember this being a pain in the ass last time. Getting this bottom clip on was not fun. So we'll see what I can do here. Fuck me. Well, this sucks. Well, I got it on before, so obviously it can be done. Give it the old reach around. Pop these fuckers out. Get my other hand in there. So yeah, seeing this, maybe I should have gotten a bigger box. That might be the smart thing to do next time. Fuck. Sorry, boys. I'll get her. Ooh, I got it. I got it. And it just slides down. Sweet. What a fucking mess. Oh. What a pain in the ass. Yeah. I got her. Shove these fuckers in. Sweet. What a pain in the ass. So yeah, I recommend getting a bigger box. Or get her figured out before you try to put her together. What a pain. Alright. Before I totally put her back together, I'm going to plug it in. See if it's working. Contact. Sweet. Well, it's cold in my garage. 43 degrees. Someday it'll warm up. Yep. It's going right up. You can see the cool is set. So I'm going to take this, put it in my cool. It might be on compressor delay for the fridge. We'll see what happens here. Come on. So you can change the setting on how quickly it will turn on the fridge. I got it set to probably 3 minutes, just so it's as soon as you open up the fridge door. Obviously this temp probe is fairly sensitive. If you open up that fridge, it's going to quickly, see, as soon as I grab it, temperature just rockets. It's going to quickly change that temp probe unless it's in some kind of a thermal well in a glass of water or something. So it'll give the fridge enough time to stabilize its temperature once you've opened it up to grab a beer or something. See, there we go. It just clicked. The cool is on. We have power. We can turn it off or we can turn it on if we don't want that particular thing to cool. So obviously I can write that down again too. I'll rewrite it. This is on. This way is off. Our cooling, our heating. We are in business. This is how an ITC-1000 works. It's a really simple device. It's pretty cheap. You can customize it way more than you can the pre-made Inkbird, that big green. I think it's a 308, which is probably really nice. Then you don't have to sit and build it. But with this, you can put it in any kind of box you want. You can integrate it in with the collar of your keezer. You can. A lot of guys are even using these specific controllers for their electric brewing devices. So they're mounting these inside of their controller box, and you can change the temperature this way. Run the temperature probe into your kettle and turn on and off your power that way. But instead of running your power through the unit, the 5.6 or 7.8, they will be going into some kind of a relay, so you can turn on and off 240 volts instead of your 120 volts, which is, this can handle 120 volts running through it, but you can use this to turn on and off a relay, an SCR, to turn on and off your heater coils. It's a pretty cool device. If you find it on the right deal, you can get them for $10 typically, maybe 12, 14. You can, this one, the Inkbird, you can change from both metric and imperial, the American and not American temperature settings. And that's that. It's a pretty simple build. I like this. I don't know. But anyways, guys, I wanted to just go over this, show you how it works, so someone who wants to build something like this has at least some kind of a reference on a side that's just more looking at schematics. Because if you don't have any kind of electrical background, this means nothing. And then it's kind of hard to put something together if you don't understand the nitty-gritty, the dirty, and how it's turning things on and off, how it's controlling the flow of electricity. I hope that by me doing this, you at least have a small understanding on how this actually works, and so you can better understand how to build a box and how to use it. I know there's a way to hack the computer, so you can program times on when you want to change the temperature. I haven't gotten that far. I'm not that well versed in coding. Maybe somebody out there is. If you want to comment with any kind of link with more information on how to hack these, how to have more control than just what the high temperature, low temperature, and the delay, the compressor delay for your cooling is, let me know. I'd love to see that kind of stuff. If hopefully someone can explain it in a way that's not power user vocabulary. If it's more on the home gamer vocabulary, that'd be pretty awesome. I hope you like my video. I hope to do some more things. I don't have a lot of ideas at the moment, but if you want to comment below, maybe we could talk about other things we can go over. I really understand the electrical side of things, how to look at schematics, how to understand how things are flowing. If there's anything else that we want to dig around in as it concerns the electrical side of brewing, let me know. We'll talk about it. We'll figure it out. Maybe if it's something else similar to this and you guys really want me to do it, I will buy it. I'll tear it apart. We'll figure out what's making it work, and we'll kind of go from there. But anyways, thanks for watching, guys. Cheers.